Hello everyone, today I am doing a presentation on classification of signals. Introduction to the signal classification. Signals are fundamental elements in various fields, including engineering, telecommunication, and data processing. Classification helps in understanding the nature and behavior of signals for analyzing and processing. This presentation will cover the different types of signals based on various criteria. Discrete and continuous signals. Continuous signals are defined for every instant of time and can make any value in a given range. Discrete signals are defined only at specific interval of time, often resulting from the sampling continuous signals. Understanding the difference is essential for choosing the appropriate processing techniques. Analog and digital signals. Analog signals have a continuous range of values that are often represented in waveform. Digital signals consist of discrete values usually represented in binary data. The choice between analog and digital affects the system design and performance. Deterministic versus a random signal. Deterministic signals can be precisely described by the mathematical function and predictable. Random signals, on the other hand, have unpredictable variation and are described using statistical methods. This classification is crucial for application in communication and signal processing. Periodic versus aperiodic signals. Periodic signals repeat their values at regular interval over time. Aperiodic signals do not exhibit any periodicity and can vary in irregular manner. Identifying periodicity helps in signal analysis, essentially in Fourier analysis. Energy versus power signals. Energy signals have a finite value over time and are typically of short duration. Power signal, in contrast, have infinite energy but finite power, often representing ongoing processes. This classification is important in communication and control systems. Real versus complex signals. Real signals consist of real valued components and are commonly found in everyday application. Complex signals contain both real and imaginary components, often used in advanced signal processing. And understanding real and complex signals is a key for application in communication and signal representation. Scalar and vector signals. Scalar signals are represented by a single value at each point in a time, such as audio signals, whereas vector signals are described by multiple values at each point in a time, such as multi-channel audio or image data. This distinction is important for different processing methods and application. So let's take a few examples of the scalar signals. A scalar quantity has magnitude only, such as speed, mass, volume, or time. Whereas in a vector signal, a vector has both magnitude and direction, like velocity, weight, and friction. Time domain or frequency domain signal. Uh, Time domain signal are analyzed based on their amplitude variation over time. Frequency domain signal represent the signal's frequency component, making them easier to analyze for certain application. Transformation like the Fourier transform facilitate the transition between these domains. Let's conclude this PPT and know about its application. So signal classification is crucial for effective analyzing, processing, and transmission of information. Understanding different types of signal allows for the development of efficient algorithm and systems. The knowledge of signal classification is applicable in various fields, including telecommunication, audio